is greater than 0, then f is a local min on that. And again, another thing is, so this is what David was talking about. You notice here, David, it doesn't say or undefined. You know what I'm saying? If the first derivative didn't exist there, then how the heck are you going to use a second derivative test to check? You know what I'm saying? It just wouldn't make sense. So this kind of only works when you do have, like polynomials and stuff, when you do have a first and second derivative defined. You see that? Because otherwise, it's like, what are you checking a sign on this? It doesn't even exist. Okay? All right. So then you can get even bigger than this. You can get the bigger little graphs and tables. Where's the other one? Where I'm going to put it all together in this last one in the last minute I have. So here's your function. This is on the very last one. Negative 2x cubed plus 6x squared minus 3. I take the first derivative. I get negative 6x squared plus 12x. I factor out a negative 6x. I get this and this equals 0. So either this equals 0, negative 6x equals 0, or x minus 2 equals 0. Solving both of those simultaneously, you get 0 and 2 for your critical points. So you put those into your little chart. And you put that the derivative equals 0, 0, there, and there. Then you take the second derivative. You get negative 12x plus 12, set that equal to 0, and then you get a point of inflection. So you do the second derivative, 0 here. And when you create your sign chart, you only have to check to the left and the right of the zeros in the cases. See how these are the same? Because it's not going to change even though this is here. You know what I'm saying? And you only have to check to the left and to the right. And what Sonia was saying is, once you create your chart, here's what I do with my hand. Check this as you're going. Decreasing, concave up. I go decreasing, and then concave up is this. Increasing, concave up. So I go like this with my hand, and then I go like that. So it looks like this. Increasing, concave down, increasing, concave down. Your graph's going to look like that. Decreasing, concave down,